Welcome to solverfy.
This is an awesome little problem, which will bring a lot of things together. First off, if the beads are released at the same time, they will both reach the C at the bottom of the circle at the same time. For B, we're asked to compute the time for the red bead to fall from A to C. And for that to compute the time, we use the equation for falling under constant acceleration. So we have y at C is equal to y at D plus the initial velocity at C, or sorry, then y at A, at point A, and the initial velocity at point A minus 1/2 g dt AC squared. We know that this is 0. We know that this is D, 0, minus 1/2 g t AC squared. And when we solve for AC, or the time for the red bead to freely fall from A to C, we have that time to be twice D over G under the square root symbol. For the motion for the blue bead along L, along the rod of length L, note that this is still motion in one dimension, but the thing is that we're not experiencing the full acceleration of gravity. We're experiencing minus g sine theta. And this is, most people who think that we are following this y sub b, but we're not. We're not following that distance. For part B, we're not following y sub b, which is equal to L sine theta. We're following, we're following L, not this. We're following L. This is our motion, our 1D whirl, if you will. So we still use the same equation as above. So we set 0 equals to L minus 1/2 g sine theta t bc squared. And when we solve for that time, we have that t bc is equal to twice L g sine theta square root of. And the next trick to show that they're the same is that for when you have the inscribed angle of a circle, if you have two chords, this inside angle is half of this arc length. This arc length is 180 degrees, or pi. Therefore, this angle here is pi over 2. So from that, we know that this is D, this is L, and this is theta. Because this pi over 2, remember that this is pi over 2 minus theta. The angles need to add up to 180. So we know that sine of theta is equal to L over D. So we can see that these two equations agree. D being equal to L sine theta. And that's why these two times are equal. And that is all.